So a word is a palindrome if it reads the same backwards as forwards. For example, mum, noon, madam, kayak, race car. Now, it's possibly harder to see in something like mum because it's so short, but then if you look at like race car here, the R and the R, and then the A and the A, and the C and the C, and then you're down to one letter in the middle, E. The word is effectively mirrored on itself. So if you wrote those letters backwards, it would end up being the same word. That's what a palindrome is. Now, we have actually done palindrome questions in class. We did like some practical programs with them earlier on. It was programs that I'd written before this exam question had come out anyway. So a program identifies if a word is a palindrome by checking if the first and last characters are the same. If they are, it checks the second and second last. So this is where it's going, right? The first and last character, do they match? The second and second last, the third and third last, and so on. That's what's happening there. And it's quite handy that it tells you that that's how the algorithm is meant to work, so you're not relying completely on reading it in the code, although it does give us a function here. So we've got a function called check palindrome. It takes one parameter called word, and this function is going to return true or false. Declare left is initially 0, so that left is basically the position for this, and then right is the length of the word minus 1, so that's the position for this. While the left is less than the right, so before you've reached the middle of the word, and something, if word left equals word right, so in other words, if this R equals that R, and if this A equals that A, and if that C equals that C, then move in one, so it's basically move in one place, and if it is not equal, then it's going to flag it up as not a palindrome. So effectively this algorithm is starting off assuming that everything is a palindrome, so you assume that it is a palindrome until proven otherwise. And we can see that because we've got valid palin is initially true. Underneath this we've got code that's calling the function, so we're getting the user is typing in a word, that's called user word. We've got a blank line. If palindrome is true, then it's going to show a message saying it is a palindrome, otherwise it will show a message saying it's not a palindrome. So using a programming language of your choice, complete line 5 below. Now it might be better here to look at line 5 in context. So this is where we've got valid palindrome is true because we're assuming at the start that something is a palindrome. So while you haven't reached the middle of the word yet, and it has still been a palindrome so far, then you're going to keep looking. Because once you know it's not a palindrome, you don't want to look. So what we're going to have in here is valid palin equals true. So that's my answer down here. So while left is less than right and valid palin equals true. In other words, while it could still be a palindrome. Then using a programming language of your choice, write the missing code at line 26 to call the function. So I think this is important here, the idea that we are calling the function. So it tells us what this line is meant to do. The function is going to be called, if we look up the top, check palindrome. So that's the function. That's going to be called down here. And the parameter that's going into it is expecting one parameter. It's expecting a string, which it calls word. But remember, the name of the parameter isn't important. It's what type of data it is, the order that they come in. So we're passing something in there that it's expecting to be a word. So this line is going to call that function, passing in user word. So we're going to say equals check palindrome. user word. And that's me calling the function and passing in a parameter. You see that I've left a gap at the start, so something equals. If this is a function, it's returning a value. We can see either it's returning true or false. So what variable am I going to store that in? Well, if we look at the context round about line 26, we can see that on line 27 there's this variable called palindrome, and that's a boolean because it's if the palindrome is true. And this function is returning a boolean, so therefore the variable must be called palindrome. So the missing line is palindrome equals check palindrome brackets, passing in that user word. We're storing it in this variable called palindrome, and then we're checking if that's true.